Good afternoon, and welcome to our midterm demo for our automatic Cornhole score tracker senior design project. Our midterm demo video will be split into 3 parts. Part 1 being the automatic Cornhole score tracker midterm design, Part 2 being focused on the key engineering specifications in our demo, and Part 3 the overall functionality of the system. For the purpose of our midterm demo, the following segments will operate as such. The LED lights will operate within 2 states, being when the system is powered on and when a game is won. The Bluetooth speakers will play a tone when the game is won. The control panel will be able to add, subtract, and reset score. The score display will display the current player score. And the RFID will accurately keep track of the number of bags on board for both players. The 3 key engineering specifications that we chose to focus on for our midterm demo are the RFID score delay being less than 5 seconds, the score display legibility distance being greater than or equal to 15 feet, and the RFID range through wood being greater than or equal to 2 inches.
This is an underside view of a cornhole board. For our overall board design, we have the RFID reader and its external antenna placed as close to the center of the board as we can to ensure proper coverage. The reader and antenna are also placed next to each other to reduce potential signal loss. Our control panel will be located in the bottom right side for ease of use, with the one speaker nearby and the other on the opposite side of the board for a good omnidirectional sound range. The score display is placed on the front side of the board facing the player for an optimal viewing angle for whether people are playing or observing. And finally, our breadboard design will be placed in a convenient spot near the front shown here. In our CDR presentation, we had our score display and control panel on the back of the board, but when in the lab, we decided that the score display would be more useful placed on the front of the board facing the players, while the control panel was moved to the side of the board for ease of use and proximity to the breadboard.
In this segment, we have the lights and the speakers. The video demonstrates the starting sequence and how the lights will change depending on the state of our game.
Here is an opening sequence of when a player resembles turning on the cornhole board score tracking system. On the left, we will show players 1 and 2 on the left and right respectively, and they will be designated with 00:00 when the display score lights up. And in the middle, it will show an LED light strip with a rainbow fashion color pattern. And on the right, you will hear tones resembling when the cornhole tracking system turns on. In the picture shown above, I am testing out the distance of score legibility of about 15 feet. And as you can see, that the score is still legible from my distance of about 15 feet. In the next segment, we will show manual override of player scores. We will first show addition of player scores, both 1 and 2, and then the subtraction of player scores 1 and 2, and then resetting the player scores both down back to 0. It is important to note that the tactile push buttons used in the midterm demo are not going to be used in the live presentation demo. The ones that are going to be used in the live presentation demo are the ones shown above, and they are going to be the Adafruit wired tactile push button switches, which can extend through the cornhole board and be used for ease of access for the players. These button switches are different than the ones I noted that we thought we were going to use in the paper as well as the CDR presentation. This is because we have encountered a variable because we are not using the PCB anymore. We had to pivot and switch to wire tactile push buttons, and these work better with our solderless breadboard.
Here we can see the RFID working on the board itself. The tags are attached to the outside of the backs for this demonstration, and we also have the serial terminal pulled up to view the tags being read. You can see that when the reader picks up the tag, it also reads each tag's unique ID. By introducing another bag onto the board, we can see it read both tags simultaneously. This is used in conjunction with the ability to write our own data onto these tags to split the tags into two separate teams for easy scoring. When we remove a bag, we can see that it's back to reading only the initial tag, and when we remove both, we can see that it detects no bags on the board at all. Here we have our RFID range test through the wooden frame of the board. We specified that the RFID be able to read through at least 2 inches of wood at minimum to ensure proper communication from the underside of the board. Our RFID passes this test no problem. For our midterm demo, we used an Arduino Uno to interface the RFID reader rather than the RP2040 as planned. This was because of some unforeseen issues during the testing phase. We decided to show our RFID on the Uno to show our work for this demo, but proper integration is at the top of our priority list.
Part 3. Overall functionality and progress. Our LED lights and Bluetooth sound system is almost complete, working with multiple game states, and we're just waiting on the completion of a few other parts for completion. The score display was successfully integrated with the lights and sound system, and we got the RFID reader working on the board and able to successfully differentiate between the two teams for a very basic game right now. We decided to remove the color sensor from the design due to complications and some logistical issues, and the basic steps of overall board integration was successfully planned out. What we still need to do. Top priority right now is successfully overcoming the issues with RFID integration on the RP2040. This shouldn't take too long, but it is vital to our project. With the removal of the color sensor, we also need to test possible alternative solutions for hole detection. The front runner right now is an additional cheap, low-range RFID board running inside of the hole to detect the bag that lands inside of it. This will be tested over the coming weekend and discussed at our next meeting. We also need to incorporate the battery power supply and finalize the component placement on the board, including the control panel. We have a lot to do, but with this timeline, we believe that this will all be possible given proper time management, barring any more major setbacks.